Hola, hola chicos, hola, ¿qué tal? Em, Primero que nada, mis disculpas por el video anterior. Eh, Sin duda no se escuchaba nada, amigos, porque el audio estaba muy alto. Perdonen, voy a intentar tener cuidado la próxima vez. Em, en fin, voy a intentar hacer un repaso de lo que hablé en el video pasado, porque creo que es importante para entender qué es lo que estamos haciendo. Además, creo que también es importante considerar de que el canal es en inglés también, así que voy a hacer un poco de Spanglish también, pues porque pues, nuestros amigos anglosajones seguramente lo van a agradecer, ¿no? Ah, de cualquier manera, como lo pienso decir en todos los directos. Mm, si alguien gusta hablar en español, puede hablar en español y puedo pasar a hablar en español. And if someone wants to speak in English as well, I can switch to English in any moment. So just be free to speak in Spanish or English. It's okay for me. Just those two language, okay? I don't know any other language. Um, well, I think I cannot. I have to also introduce myself. I am. You can call me Alter. I'm a programmer, and what I'm doing here is coding a game using C++, and I want to code this game using entity component system. I mean, no, not just that, of course, but what I want to do is make a render that is also um, supported by other systems like the entity component system. I'm using some libraries to achieve that, and I think it will be fun. I I had done some progress so far, which I think is pretty decent. Of course, it's by far not complete yet. Uh, but, but but of course you can take a look. Um, and see what I'm talking about um, this thing that I have done so far. Uh, Sorry for that. Yeah, here we have it here. Uh, this is the thing we have right now. I mean, visually is this because behind the scenes there are already a quite amount of code in this at this moment to achieve this. We have, of course, some odds and ends, simple things to resolve. For instance, the transparency of the texture. This is a thing is not enabled yet, but it doesn't matter. I mean, this is kind of easy to fix. So I focus most in things like is more important things. Okay. And yeah, we have movement so far. We have some map rendering. Um, yes, I'm using pretty good software to do this, which is called Tile. You have maybe you have heard about it. This is it's like an editor where you have tile sets and and you make the map from those tile sets. It's this one. So far I have used this software to make uh, this this map you see in the render. I have created this using using a Python script. I had created this thing using Python script. Um, so I think it's not that clear right now because it's kind of just showing you the things I have used, but it's not that hard to understand. Let me try to explain. It's, it's like this. I have this software to make this the maps using some tiles of actually examples. So this is just a proof of concept. This is not the final tile set. Actually, it's title for an internet, and I use this software to create a file, which is a JSON file to be clear. And this software is made by actually it's the name, buried the name of the author here. You can find it. Yeah, this could be the author of the software is pretty good software. Uh, um, because it's kind of complete. So you may consider it donate if you want to you want to use it. I had to do myself as well. I think it's I actually uh, testing the software and I think it's pretty nice. Yeah, this guy is pretty is a genius definitely. This is pretty good software indeed. Um, and yeah, I use as I was saying, I use this software and create a file. Each of map and layers and all the information you see here is made of. It creates a file, and I use that file in a Python script to generate my map. What I do is create out of the JSON, create a binary file, and that binary file uh, it's it's read by my C++ code, and then the render takes this new this read data and then renders the map itself with the proper resolution, of course. So so far I have this, and uh, and I am happy. I think it's quite a good achievement. And yeah, let's see what are the next things to do. Um, I know there there is a lot of things here. There are a lot of things uh, to say about this software I have so far. I will explain in my streaming, and if people ask me things, I will of course answer and try to explain so far what is the other modules and the other code I have here. Yeah, I think it's quite nice to share this type of things. There could be people that it's interested also in this type of game development using this type of approach, you know, because this is just an average. Some people use an engine and then they go straight with the engine, and other people do like this, and other people uh, code for web apps or for web games as well. So it's different approaches. So I decided to do this because it's kind of fun. It's you learn, and any approach you learn anyway. But yeah, let's get into it. In the past, in the past streaming, I was talking about how to include state machines, how to include states per entity, and uh, and and make some and make some code which is specific for the state of the entity, right? We have this type of pattern uh, where you want to split the behavior of an entity in different states. This is of course the state machine. It's a quite common pattern, and I have done some notes for you guys because I think that is the easy way to explain this. I have done this. I took some notes from the past streaming, uh, where try to explain, but of course the music didn't allow me to do it properly. So I will try to explain again and say that this this is the things we have. Currently, we have entities, right? We have entities in the world like like a character, an NPC, an enemy. Currently, we have, of course, the main character in our world, which is the entity or the entity. Because of course we want an entity that controls the character of that interact with the world. And so what I need to do is uh, establish an state machine for that entity because I want to split the behavior of this entity in several states, which at the end represents different files, different source files, right? It's it's a way to separate uh, the implementation of each behavior. So let's take an example. For instance, idle state is a of course is where uh, the character is just not moving, right? And we have to perform an animation of idle animation, and then um, yeah, just be there, right? Just exist, and yeah, other things may that may be may apply in the future, but that is the point. Uh, after you have seen this, like state machine is to separate the behavior. You will see clearly that what I want, what we want to achieve is just separate the source, the code that control that behavior, and to avoid to have that messy source of with a lot of lines and that stuff. No? But anyway, continue with the example. Just imagine that you start moving the character, and of course you have to transit to the next state, which could be walking state, right? And then of course you have to perform different animation. You have to uh, act accordingly, um, like make some collisions and all this type of stuff. Take damage if you hit something that damage you, and that's it. Then different stuff, right? So in the past video, uh, I was trying to figure out how to interact with that state machine, right? And we decided to put that state machine into a component. Right? I show you guys that in each entity we have several components, right? That is the whole point of system called entity. Sorry, let's see what happened. Oh, that's it. Entity component system, right? We have the entity, we have the component, which is in this case this thing, the component, the state machine. We will handle like a component, and then we have systems. The systems are the those things that you use to modify the component. It's like it's like uh, having a machine which has an input right here and an output right here, like this. It's kind of simple to understand. And so when you have entities with components, you make like a loop from, sorry, a loop from entities, from all entities, let's say. And then you take the component you are interested on and send into the system. let's say this is the system to modify component or X component, let's say. In this case, our component is in state machine. And so for each entity, you put that in the system, and then out of the system, you have your component modified, right? This is kind of the, the way you understand when you have entity component system implementation. According to the theory, this is a good way to make games since they are uh, good to parallelize with threads. Uh, and the whole system also is efficient because each component represents plain old data. In this this plain old data, all data fit pretty well in the cache of the system. I mean of the hardware. So you reduce the cache misses, and then that's why your code runs very efficient. This is not the deepest explanation I know, but it's a way to explain, guys. Maybe I can go into more concepts in other sessions, but yeah, it's the way to understand how to make this, how to address this type of systems or implementation or approaches. Yeah. Anyway, let's continue with the explanation and so I have now this component and I wanted to figure out how to address the fact where we have several states because it's not like uh, we want iterate for each state. We have to be focused in that we are in one state and we have to perform the action of that state according to the behavior that we are doing right now. Let's see how is a state inside, okay, in the code. Let's see how is this state. Let me find. This has to be an enemy enemy factory. I have this factory, which is also a pattern in software development. I have this pattern where I create my instances of entities. For instance, this function create the the main character you see in the scenes that we have right now, and I put all the component that this entity needs. Okay, so for instance, I use this function in the registry to create an entity, and then I save that entity because I know that is the main entity, right? So I want to save it for further uses. I don't want to have several players. Uh, I mean, several characters that the player can control because it's not the average use it in this game. Uh, and then I use that entity and add several components or all the components I need. Right now, I have identified this type of components. Okay, so I can explain this more in details in the future videos, guys. But this isn't like they say a big picture that the thing we have right now. Um, and yeah, this is the component that we are addressing today. This is the component of a state machine. As we previously, as I previously said, uh, we are trying make give an entity the component of that defines his behavior, that control his behavior, that address his behavior. I don't know exactly what's better to use, but that's the point. Um, So we have this state machine component. Let's see it. The state machine component has a state behavior, which is the current behavior. And what exactly is a behavior? Well, a behavior is a state. And what we have here is the way that the state, I like to define the states, let's say, because it's not the way, it's our way to define the state. I like this type of definition, um, because it's kind of standard. If you look at some other software, how they implement state machines, I mean, any software that have an implementation of state machine, they mostly have an enter, change state, and run and exit function. Actually, these three functions. This is the way you define pointers to the function. Um, this said, this is a function that doesn't return anything. This is and doesn't receive anything, and this is the holder. Let's say the holder for that function that have that characteristics. No returning and no parameters. This is the holder. So if you assign a function to this enter, it has this type of definition. No void return and no parameters. Let's take this to make the example for one function that receives an entity. Yeah, this in this case is a constant reference, and um, and yeah, it's a a function also doesn't return anything. And if you assign a function, has to have this template, let's say, this aspect. And so, why is this is important? Well, just imagine in our diagram, well, in our sketch, the entity is in the state that is the current state, the current behavior, this one, and we have defined that the current behavior is idle. So in the idle, we have to make in the run function, we have to make the things that defines the idle state. In this case, we have to, for instance, play the idle animation, and well, the idle animation is the thing we already have, right? Um, the things you see in the in at the moment of running this game. Let's run it again. Okay, it's doing it. Yep, yep. Currently, we have the idle state. The animation is kind of hard coded, and when I'm moving, it's still playing the idle state. So what I need to do is change the animation when I move. And what I mean by change is to change the behavior of the state machine. So right now we are in the idle state here, but I want to move transit to the walking state. Yep, that is the difference. And here, when we move to this state, we will have an animation different than this animation. That's the whole point. Okay, I think that is very clear. And now how to do that, right? Because that is what is to be done, but how to do it? Well, there is something they have to consider when we use state machines, and it's like it's this entry point, is this um, point which is a representation of the moving this or executing the states inside. What I mean is when an entity has a behavior, it's it's reproduced that behavior through the state machine as a whole. No, know the state separately. So it's using the state machine, in this case, the state machine component is using the state machine component that the entity will use the state inside. So we need an entry point, just an entry point, because what function in the state behavior you are going to call when you are, let's say, in the idle state, and in which moment you are going to call it. Yeah, it says where exactly you have to call all those four functions. That is the whole point. That is the hard part, let's say, right? So we don't call it. We don't call those machines, those functions, because what we are going to do is call a single function, an entry point, okay, an entry point of the state machine component, or the state machine, to be said. Um, so and what that was the matter in the last video, and we were thinking and implementing a singleton to do that, this thing. And guys, I thought it could be a good idea to just to make a function uh, that get calls when we want to move the state machine or execute the state of the state machine. Not doing a singleton, I think, is we can address it differently. So we are going to change this, and we are going to create like a system where we said that by updating that system, we are going to move the state machine of an entity. That is exactly what I'm talking about. So where to call it? Yeah, where we saying that is the good point to call it is in movement system. But I also changed that. I also changed that guy, and I will show you where I'm planning to write that function. This is another thing I had to explain before moving forward. Sorry, guys. Yeah, this was an explanation also in the past video, and I mess up. Yeah. Okay. Let's explain quickly. Uh, this is what you are looking at. This is the file where we implement the state of state machine. In this case, this is the gameplay state machine. Let's see it, right? Gameplay state machine here. This is the definition of the gameplay state machine, and this is a different definition. I mean, we don't approach this state machine like the state machine of an entity, because it's a global state machine, to be saying that way. I call it gameplay because it defines the states of the game itself. Uh, what I'm saying is, uh, just imagine that you are starting the game, and that is in a state like the initial screen, yeah, and the running screen and the presentation. So I can just add a new state and separate all that logic from the from this main screen, from the welcome screen. I separate all that logic and put it in input the code and those functions, and I just reduce the things I had to deal with when I do that, right? So imagine I have uh, an intention to work in that screen in just that part of the game in the at the beginning. I just focus in that functions in those source, and is if something is broken or is not working properly in that screen, in that splash, it, it probably uh, it's likely it will be in that code. So that's the advantages of using this approach. Okay. So the explanation continues saying that I have two. the states so far. One is the run state, like when you are in the game. This state you see when we run the game. And this is another state, uh, which is the state for when the game is paused, right? This has some code as well, but it's not kind of complete. So we are going to see it in another video, guys. Um, I- yeah, yeah, we are focusing in fixing the estimation of an entity. Okay, so you can see here we have the state machine, the state of the state machine similar to the state machine of the entity. Uh, where was it? Let's close this, move here, and say, let's look at here, here. Yeah, you can see here. Oh, well, it's not exactly how I expected to see it. No, let's see it in the. Sorry, let's see it in the create enemy effect here. Here is the initialization of the current behavior of the state machine component, right? This state machine has a behavior, as we said, and it has the functions, and then here's the initialization. It's like here. So we have here an array of states. Here we have an array of state of gameplay state template type, and we initialize this in this way, and it's kind of similar to this. As you can see, this state has two more function differently with this state, uh, because of course each state has to process input and also has to update and render, right? So I need these functions as well. So this is state machine template is different than this state behavior because it's yeah, this is for gameplay and this is for entity behavior, so it's different, right? So let's see where is the entry point, right? That will help if we see the entry point of this state machine. Well, let's go into main CPP. This has a lot of code which is not usable. Actually, it's just proof of concept. We have to identify this part of the code here. This is the where anything starts, and we are going to see the loop because this function loop calls the main loop of the game, right? It's where all the things are repeated in render and update and many things more. This is the function where we are going to put the entry point. So just imagine that we already define our gameplay state machine with states. We have we can have more state here. We will have it definitely, and then we move this state machine using the entry point. This we move the state machine, and it's like that we don't know what is happening inside because the state machine moves according to the feedback that it receive from the outside, and it's reach this function. This is the entry point. If I not wrong, this is entry point. This actually has another function which we can consider that the second entry point, or this the functions are the entry point because this functions is called in a different place, of course, because we receive the inputs from the different functions and we update the game from a different function, right? So let's go here, here, and look at, I think it's here. Look at the, sorry guys, no, main, this function here. Here, this is process input and also is update render. I had to change the name of the function definitely. But let's look at the process input. See, process input has some code, which is not important right now, and has this process input. This is the entry point, guys. This is one of the part of the entry point. When we call this function, we actually call the state machine process input. But which process input we call here? Which one? This one or this one? Ah, we don't know it. We just know it because the the state of the game. I mean, when we run the code, we will see the the word, the render, the character. So we know that the game is in this state, and we set that state on purpose to 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 render that. So imagine that the player press the start button, and then when when the when the when the game receives that, probably here, we are going to change the state machine using one of these functions of the gameplay state machine and say, hey, it's time to change the state because we receive a signal from the player that presses the start button. So we have to change the state, right? And at that moment, it will move to this state, and it's going to press, it's going to change. I mean, it, it won't realize, but we are going to continue calling the process input, but internally the state machine is going to call this and not this because we internally change the state, right? It's kind of cool. And where is that function call? Here. Look at this. This is the point where we have we make use of this array, and we just use based on the current state which function to use. This is the whole magic of using pointers and in this situation, because we are just change the context by states, and then the state machines continue just reading the same function, but internally the machine is in charge to change which function to call according to the based on the value for based on the address that the pointer holds. That's kind of cool, right? And it's similar to with update and render. And that's all, guys. Uh, so going to gameplay run state, it's just that. See, we have here the process input, the update. So when the state machine call the functions, we just go into this source and we call the respective functions. And as you can see, it's just this code. And if I want to change something for the state of the gameplay run state, I change here. And if I have a problem with this, it would be here probably, or at least it would be the starting point. So perfect. So I think that helps to explain what we are going to do. We want to do something similar to the behavior of the entity. That's all. We have to we want to do something similar. Um, okay, so let's uh, let's let's go let's go back and the previous things we have talking about, which was where to call the entry points. As we have seen, we have for our examples in gameplay state machine, we have here. This is one of the entry points, and this is the other thing of the entry point. This one. Actually, we didn't see this function here. Look, application instance update. Similar with the application system render, right? And all these things get called here. And then they decide if call run or pause. That's it. So the entry point for the state behavior, state component, state behavior is identified could be here. Okay, uh, in the update, the update function of the state. And I because I thought, okay, if I want to change, for instance, things related to update, updating the entity means make things in the on the update function. So I decide to put in here like a function that it's going to use the state component of an entity to to change behavior. So let's look at this end of the function here. Here we have something similar as we had in the state machine of the gameplay. See it? But this time for each entity. I think it's going to work at least uh, at least it has a good average because we we are going to iterate for each entity, take the state machine component of that entity, and we are going to use the current behavior. Yeah, you remember this is the state component current behavior, right? Is the current behavior is these things similar to the gameplay, right? It's all connected, guys. I think it has future. It has future definitely. But yeah, let's continue. In this moment in the update, we had to make a call of the change state of the behavior because we had to verify if we are going to transit. I think one important thing I had to do is also explain the purpose of each function that is be going to help. Um, but normally, when you have a state, you have an enter function which represents the moment you go into the state. It's normally called just one time. Is at the moment of the end of the entry of the state. For instance, if you have idle here, you probably have some things in enter function that's prepare the the to prepare some aspects, some things for the state to work, right? It's something like that, and similar to all that state. Actually, it's kind of template you can modify if you decide which will be the functions your state your state we have is going to have. You can change. It's like a template, and so that means if you don't have sorry guys, if you don't have anything to put in the enter functions, you just mm, leave it blank. That's all. Um, and yeah, that's the enter function, guys. Then the change state is that function that evaluates conditions to to know if you have to stay in the state or you are going to move to the next state, regarding of the conditions you met. What I mean is, imagine we are in this idle state, and we only have the possibility to move to the walking state because yeah, that is the diagram right now. But we can also have another state where we can move like that state. We can also move to that state uh, because yeah, if we are in idle position and we get shot, we can just transit to that state. Is also a possibility. But this transition we have different guards. It's just the technical word to use, but it's also condition. We can say condition. This guard, this sorry, this transition has different conditions than this condition, than this transition. Sorry, because yeah, imagine that it will be the same conditions. So this state machine has to be deterministic. It's not possible to have similar conditions because yeah, that doesn't work, at least in this context. Um, but yeah, we don't have this dead state, so we only have this one. But of course, you have to identify the state. You can transit from one to another, and based on that, you put in in the function change state those conditions. So if you met the conditions for being dead, you evaluate that condition and you transit that conditions. Pardon, sorry, you transit to that state. And similarly with the walking state, if you meet the condition for walking, so you transit to walking, and and that's applied for all the state machine. Excellent. Then run state is the function that you that where the all the uh, let's see where the logic of the state is applied. Like things you are going to do where that is going to iterate for the game. I mean, that function contains the code that will be executed every single time, or the frequency you want to execute. In this At this point, we are thinking that those function is going to be executed every frame. So this things execute once, this one probably every frame as well, because we have to check every frame if we have to move the behavior, right? This state, but sorry, this function has to also has to be called every frame. And this functions is similar to enter, but of course, as I said, it's self-explanatory, right? It's also is only called when we move to another state. When we exit the state, we go uh, into that state, into that function, sorry, and then we move to the next state. It's used to this to disable some stuff if we need to disable to prepare the state to be yeah to be replaced for the state. This is kind of the logic we follow using this. Of course, again, if you don't have if you don't have anything to put in the exit, just leave it in blank. Okay, so let's go where we are here, right? So we will do every single frame. We will call this function and this function according to the behavior. So let's try it, okay? Let's try it. Uh, then some breakpoints here. Um, and then we are going to look at enemy factory. I know the name is not it's not the proper name. Call it enemy factory. It has to be character factory or something. But yeah, guys, we are going to change a lot of things um, in the future days because yeah, that's the way to do it. You make this iterative process of making software. This in this case a game, and you change several things. Is the way to do it, guys. I mean, going exactly with the names of the at the exactly moment that's I think it's not a good practice. Probably some guys, some programmers, coders can do it, but I don't know exactly if they just come from something out of the mind and say, yeah, this is going to be the thing, or the code we are going to use for the whole development. Yeah, you most likely change things. Okay, here we I initialize this state machine component with the current behavior, which is based on the idle state. Okay, so that means we are going to use the entity is going to start at the idle state, right? This could change. Maybe we can put a parameter and say which type of behavior we want this this entity to have. But by right now we define an idle state, an idle state. So, where are these functions? Because when we define our gameplay state machine, we have functions here, and we have these functions in our files gameplay game run state, which are these functions. So, where are these functions? Pretty much the same. Pretty much the same here. Um, sorry, are you going to drink a bit of water? Yeah, I was saying it's pretty much similar. We have also files where we define these functions. Of course, remember that these functions are per entity, right? So it is per entity, but all the entities is going to execute this code. So you have to be clear that for each entity, this code is um, will be the code to execute. So we can probably distinguish between NPC entities and player entities or character entities, playable characters entity. Sorry, state functions. So maybe in the future we change this like NPC idle state, change state. I don't know exactly right now, but it most probably could be, probably. Okay. Um, because because it's not like what happened alter if you put a parameter here saying like bull is NPC. Mm, I don't know because we will probably fail in saying that but here we have to have an if condition if it NPC or not, and we will start just uh, fail in the fact that we want to split or separate codes, separate implementation, right? And I think it would be better if we distinguish between the states. Um, yeah, it could be better, but we don't know yet. Probably this is the way to go or not. Yeah, we will figure it out in the future, guys. Anyway, um, here here we have the function. So yeah, we can make some things. I already advanced because I have thinking about, and while I was thinking I was putting just code to show you guys. So yeah, let's finally execute this thing to see how it works. mm, it's going to stop the create player. Yes, in create player right here, I guess. It's not to give me anyway. I just played and I reach this function. This function is the function of the entry point, right? At the moment we have it here. I think it's the right way to put it. Uh, yeah. Then here we just collect those entity that has state machine component here. And as you can see here, when we go into this function, we will go into the idle state here, idle state change. You may be thinking, Alter, but you didn't go to state enter. So that's why. Yeah, that's a good question. Because we didn't identify the place where to put the enter yet. Probably would be in the enter function of the state machine. This one, probably here, like here when we just create, we we call the enter function, right? Probably. But yeah, that is a good call, definitely. Anyway, if we advance, we will see we go into the run function, which is also the idle state, and here we have a lecture of the anim component. And this is the new part I would like to add in this video, guys, because here we have reached the state of this part of the notes. Because right now what we have is a sprite, but we want to change. The, one of the things why we are want to use the StateMachine is to change the sprites, right? Change the animation when we move and and other stuff. So I was thinking how to change the animation accordingly. Okay, so right now we have a set of sprites uh, in the sprite component. We have some information about the sprites, and we have to make or figure out a way to change by using that animation to change, sorry, by using this information to change the animation. Let's look at that component that has to be an enemy factory as well. Here, spray component. Here, this is the information of the spray component. As you can see, is yeah, it's a texture ID. We have texture coordinates, uh, width and height, dimension of the sprite, dimension of the texture, the amount of rows in the sprite, and the amount of columns. Let me show you the sprite we have. It's it's pretty nice. The artist of the pixel artist is really nice. I think his name is Leo, and he has a very good pixel art in my opinion. Okay, I'm not an artist. Look, they're very nice. Um, I had done some arrangement of this whole texture uh, because I have done some test, and I think right now this is the right way. Probably I will change in the future as well, but anyway. And the animation, I did the animation like instead of six columns. Here, here is one animation. Here is another animation. Actually, this is the idle animation. This is the bar we have right now. This is the idle animation. Uh, this is the idle animation for this angle and so on and so forth. You can see it. So right now, when we actually walk in different directions, we have to change the animation. That is exactly what we have to do right now to see if our StateMachine works. Okay. Um, to make the animation, we have this spray, right? And I was thinking one of the approach could be same that we use in the map to make the map, but I think it's not necessary. Hmm. Because because we already we have already defined the animations in the animation manager. I was thinking, guys, let me explain this because it's not going to be just random stuff put in the notes. Um, to make the map, let me show you guys. To make the map, I think it's this one. To make the map, we we took the approach of reading the image like it was just a row, a huge row of images. Put in this row in at the end of this initial row, and then the second row. The second row, 0, 1 to second row. Put it in the end of the first row, and so on. Why? Because the function we define. Let me show you guys. Let's close here again in a round state. The function we define, guys, to read the sprite coordinates, the texture coordinates for the tile set. Sorry, is this function where we have an index. So this index represents an index in the whole vector of our texture. I know it's a squarey texture, but in the data of the code, we represent that as a whole row, as a whole vector. So the index is kind of like that, and the index is transformed to this code using this code. It's transformed into the right coordinate using the columns and the rows, and with that we just read exactly the coordinate uh, where that texture or where that piece of tile is. This is very clear by or maybe not because it's in. I would like to show you. This is the thing you get when you use tile. I mean, I referring to this code. Sorry, this program. Each one of this tile has an index. This is yes, 00 with 6 7 7 7 7. But this index you see here, right here after the two numbers, right here, this is 40. That is the index I need in order to make use of this tile, which is in this case is 0. So this is 0. This is 1. This is 1. So I wanted to use the same average. Uh, right here we have uh, 18. So if you count uh, one of this, each of these rows in this first column, you will see that it's a 17, and then you continue with 18. So this is it's kind of putting this row at the end of this row and continue, right? So I wanted to use this average, and this is the place where you go where that data is coded. This is base 64. I found this useful to be read, and then I transformed this into another code. Use it for C++ to use it. So, but yes, this is the source of our maps. Yep. And using this Python code, I recode using binary, uh, and then transform that, and then read it with C++. That would make sense in the future, guy. Right now, I just want to show you the whole the whole things about the things we want to explain here. And yeah, I thought, well, a good idea could be just doing the same that we did in the map. But I think it's not necessary. Right now, I'm thinking it's not necessary because we already have this one, Animation Manager. In Animation Manager, we have unordered map. This unordered map is, uh, yeah, a map for all the animation we have. This is, yeah, it's like having hard-code animation, hard-coded. I don't know if this average is the best. Maybe we change in the future, but we are not certain. Yeah, I'm not certain. Yeah, we will see it, but right now is this one. So using this function, get animation, uh, by give it to this function the entity type, the animation type. Sorry, it has to be. animation type, no entity type. Maybe because I copy from here. So yeah, let's change in animation type. Okay. By giving the animation, I read the animation from the entity, um, from the map of animations. Let's search that animation map. Has to be a place, or maybe it's this function has to be a place where we add animations. Has to be this one. This is what I'm looking for. Yeah, as you can see, this is another factory where you create the play animations. Yeah, you said, okay, there are several animations. Right now it's idle animation, walking animation, walking animation, and so on. And they are defined just here, right, coded. Yeah, I mean, this is not different from other uh, approaches using engines. Like, for instance, if you define an animation, um, well, actually, I'm not sure if Godot does this like this, because if you define animation, they are going to store that animation definition in a file so the game can use it after that. Maybe it gets codes, it get code in a way. Um, Maybe we can do that also instead of hard coded here. Hmm. I don't know, guys. Okay, but at the moment, let's use it. So we are going to change according the according to state the animation in this map using, of course, the function I already showed you guys. This function, actually we already use it here. Animation system. In an animation system we call that animation, see, and based on the animation type. So in the animation component of the entity, let's collapse this and this. In the animation component, guys, in the create layer here, we have animation component, this one. And animation component, as you can see, guys, the animation type is the player and the kinematic animation value is idle. Okay, this is the definition. It is defines what kind of animation we use. Yeah, yeah. I remember why I use animation component and idle. Just a moment, guys. Okay, I was saying that. Yeah, now I see it. Hmm. Okay, guys. I think we have something right now. Pretty pretty good explanation. I think with this we had now fixed the previous video with all this explanation. Uh, yeah, yeah. We will continue tomorrow. I believe so. I think it's a good place to end because if you see here, if you see here, look, it's not gonna be so hard. Bear with me, guys. I think we identify the right place. Look, look. Here, when we move to idle state, we just has we will has to change kinematic idle state. Here we just has to change what kind of animation to play because when we move kinematic any value, if we put idle here, it's not going to work because it did the namespace. So when the function get out of this, is going to be it's going to be yeah, it's going to call this in this function, but when it goes into this function, this value, since we change since we change here the animation value, so it's going to read the idle. So that means if we do the same in the walking state, uh, just by changing the kinematic any value here, when the code reach this point, it's going to read the walking state, and then the animation is going to change, and it's going to work perfectly. Yeah. I see it. I see it. Yeah, I think it could work. It could work. Um, the the only part is missing is this change state. We have to work on this tomorrow as well because yeah, we need to figure out when we change the state. Exactly. I mean, it's pretty obvious when we move the character, it has to change, but based on what information, based on what component and which data, probably will be the moving component, guys. Probably. Yeah. Yeah. Let's put it in here to remember tomorrow. For so we can remember tomorrow. This is going to be control system, which is I think is in player control system, movement component, move component. Yeah, right here, guys. So if it's moving, yeah, if it's moving, we have to move to the next state. Here, guys, we have to let's put some to do. Sorry, guys. We we have to call to set next set next date, something like that. StateMachine to change to the next state. This which is walking, right? Yeah, perfect. I think it could work. We will do it this tomorrow because we have to create also the file and assign the function to to the state, to the behavior. Yeah, we have to that is going to the thing. It is going to be a thing to assign the new behavior. That is going to be another thing. So what I mean is how we can how we have how to change enemy effect. How to change, how to assign this, how to change this. Now it's going to be a different behavior. Hmm. I don't know how to address this guy. I don't know yet. Yeah, we will do it tomorrow as well. Yeah, I will figure it out, guys. Definitely. Anyway, guys, thank you very much for seeing this video. I didn't have any audience streaming right now, but if you see this in the future, thank you again. Thank you for see the stream, and I hope you have learned something. If you want to share something with me, also just let me know. Uh, yeah, thank you guys. I'm Alter, and I will see you probably tomorrow. Bye bye.